simple terms. Okay. Are we good? Yeah. Good. Up here? Okay, so part 1 is polynomials, part 2 is quadratics, and then part 3 is quadratics again. Okay, so we're going to do the first part together. Alright, so Veronica, you love to read, so can you read the first part right here?
Wait, so this is optional or?
No, not that this is optional, the highlighted piece right here.
Given the graph at the right, what are the roots and multiplicity of each root?
Okay, so for this, I told you guys need to know multiplicity for the final, but you actually do. Okay, so how many roots does this polynomial have?
2.
2 that we can see. What's the first one? Okay, so we'll go 1, 2, 3, -3 is one of them. What's the other root? 0. Okay, so if I want to write it as a factor, how do I write a root as a factor?
X plus 3.
X plus 3, right? We just flip the sign. It's after we apply zero product property, right? Okay, how do I write 0 as a factor, though? Just as x, good. Okay, multiplicity, who remembers what multiplicity is?
The terms of your graph? No.
Not quite turns, but it has to do with how that turn happens.
Min and max? I don't know.
Not a min and max, but that also happens to be with turns.
Is it like bounce?
Yes, bounce, and then there's one where we just cross, and what's the last one?
The squiggly line.
Like the squiggly line, okay? So this one, what is this root doing right here at -3?
It turns.
It's bouncing, and it's turning, but, so if it bounces, what type of multiplicity? 2, good. Okay, and then this one just crosses as a line, so what multiplicity do we have here? 1, okay? So this means we have 2 roots here and 1 root here, and that makes sense because this is a cubic polynomial, meaning we have 3 roots, right? But we only have 2 terms, or we have 2 terms, and it only looks like 2 roots, but since we have 2 here. Okay, so we're going to take these factors and we're going to write them in factored form. How do I go from here and write an equation in factored form? So it was like x minus root 1 times x minus root 2. That's kind of how it looked on the study guide. So how do I take these factors and write an equation?
Is it?
It's okay. How about
Can I guess?
you turn and talk to somebody about how you might do it real quick. Turn and talk at your table. How might you write it in factored form? How might you write it in factored form?
X minus it? Oh, it's like that.
Is it like this?
Like that. I thought it was just supposed to be like.
It's like multiple.
What about the 0?
Okay. All right. I think Daniela has it. Wait. Okay. Now I'm gonna ask Daniela. Wait. In a second. All right, Daniela. What are the factors, or what's the factored form?
X and then parentheses x plus 3.
X plus 3. Did anybody get anything different?
That's what I said.
Raise your hand if you got this.
Me.
Okay, like so. Did the rest of you participate? Did you try, or you just copied? Try. Did anybody get anything different, Alondra?
The square, like the little square on top of the thingy.
On this one, why do I need to put a square here?
Because it's, I don't know. It's
Because the multiplicity is 2.
Because the multiplicity is 2. If I were to do this one, right, if I were to do x times x plus 3, and I were to multiply this out, I'd get x squared plus 3x. What kind of polynomial is this?
A second.
A second degree polynomial. What shape does a second degree polynomial make?
A U parabola.
A parabola. Yes. What is this? Is this a parabola? No. So we need to square that. That makes sense. We have a multiplicity of 2. Okay, last part is to get it in standard form. What do we do to put it in standard form?
You multiply.
Multiply it out. Do you guys want to use box or foil?
Foil.
Foil. Okay, so I have x and x plus 3. What am I missing?
Another x plus 3.
Right, because I have squared. It's not x squared plus 9, right? We just expand it. So if I multiply, everybody should be able to participate in this. What's x times x?
X squared.
X times 3. Okay, and I'm going to take that and I'm going to multiply that by x plus 3. So I'm going to go again. I'm going to say, what's x squared times x?
X cubed.
X cubed. X squared times 3.
3x squared.
3x squared. Oh, that's a bad squared. 3x times x.
3x squared.
And then 3x times 3.
9x.
Okay, I'm going to combine like terms. What like terms do I have? last part is,
X cubed.
oh, it is cubed. It is cubed. Good job. Okay. And then last part is what?
9x.
Plus 9x, right? If we look at this, this makes sense, right? We have a third degree polynomial. Oh, we made an error. Okay. If anybody who can find the error, I'll give you $100 million.
Wasn't it?
Can you repeat that?
There's an error. We made a very, very tiny error. Okay? So think about, you know what you could take out? Take out your end behavior notes. Take out that little note card, right? There's one tiny, tiny error we made on this.
Where we get more money?
Yes, you can get more money for this.
What if I
$100
don't?
if you find the error.
It's
Take out the note card.
It
Where's
has
the
to
note
be
card?
negative.
Whoa. Yes. Why does it have to be negative? Who knew that? Wait, did you know that?
No, I said I'm gonna take a guess and then I said
Okay.
My sister's smart.
Why does this have to be negative?
smart.
Sister's smart.
Because the parabola starts in the negative side? Because it starts in quadrant 2 and then it ends in quadrant 4?
Right? If we had a positive cubic function, we would start in quadrant 3, right? This would be our positive cubic function would be over here. But this is a negative cubic function because it's reflected. Good catch. And I owe you $100 million.
What if you give me
Okay. You can turn in that $100 million for extra credit points. Okay. Alright, so here is the first example. Now you're going to do that with what kind of function? This was a cubic, focus in. A parabola, and then on the back you're going to do vertex form. Okay? So you have,